Hi, in this video we'll talk about the basics of everything in the universe, that is math and then the number systems. Most of us are accustomed to the decimal number system we use every day, like numbers 0 to 9. There is one called binary with two positions, either 0 or 1. 0 is off, 1 is on. That's how all the computers, supercomputers work. But there are two other number systems which are very important for the computers. One is called the octal number system, one is the hexadecimal number system. So even for programming the C and Java, we need to know about all of these. Before you start coding C, Java or any other language, you need to understand all the number systems. So in this video, I'll explain some basics about the number systems. And next video, I'll talk about how to convert a number from one system to another. Okay, decimal number system, we are very familiar. It's 0 to 9, 9 to 17 I have put there. So a decimal 0 is binary 0, octal 0, hexadecimal it's 0. Decimal 1, it's all same. But when it comes to number 2 in decimal, it's 1 0. We shift one position, 1 0 in binary. These two are same. If you observe here, till octal has 8 digits, so 0 to 7. 0, 1, 2, 3, 4, 5, 6, 7. So it is same as in decimal. Likewise, hexadecimal is 16 digits. This one has 8 digits. And 0 to 7. So 0 to 7 all same in decimal, octal, hexadecimal. Where octal it changes to 1 0 is when decimal is 8. So when you say number 8, it's in decimal it's 8, hexadecimal it's 8, but in octal it's called 10. I will discuss about it in detail. So if you observe here number 3, you have to add 1 to here. That's number 3. For binary, we keep changing the positions. Then you shift 1 left side. So decimal 4 is binary 1 0 0. Decimal 5 is 1 0 1. See, I added 1 here. I changed the position. Similarly, this 0 becomes 1. This 1 becomes 0. This one remains same. Until here, decimal 8 becomes 1 0 0 0 in binary. And we don't call it 1000. It's not 1000. All these things are not the decimal values. It's binary. When you say binary, we should not say binary 10. It's binary 1 0. Binary 1 0 0 0 means decimal 8. And this is the first part. So number system decimal 0 to 9. Binary is either 0 or 1. Octal is use 0 to 7 digits, 8. Hexadecimal is 16 digits. In hexadecimal, we use numbers from 0 to 9 and then we use the alphabets A, B, C, D, E, F. That's how number is represented. But 16 digits. All these are helpful in the C language because C, Java and other languages are dependent on the memory storage. When you define a constant variable, you need some space in the memory, either in the RAM or on the physical storage when the program is getting executed. The lesser memory you use, then it's good for the computer and for the program too. It will execute faster. So all these things we need to know before coding C or Java programs. And most of all calculations are done in hexadecimal inside the computer. Kind of assembly language. I'll have a separate video about the assembly language and how calculations are done inside the computer. Once you hit the execute, a lot of things happen inside the computers. Basically all are zeros and ones. And quantum computing is another higher level. It talks about different positions. We talk about either 0 or 1, like 1 is on, 0 or off. But in quantum computing, it's many steps higher. So they're talking about positions which is in between 1 and 0. That can be like thousands of positions, state positions. That's a whole different area, but this is the basics we start with. Let's continue here. We saw 0 to 8 here. If you observe here, number 9 in decimal is 1001. Octal it's 11. Hexadecimal 9 is 9. Until it changes from number 10 in decimal, it becomes A, then B, C, D, E, F. So F in hexadecimal is 17 in octal. Binary, you keep moving the positions, and in decimal, the F is 15 in decimal. F in hexadecimal is 15 in decimal. Octal, it's 17. Just for an example, like example number 20 in octal is number 16 in decimal. This decimal, when you say this number, you should not say 20 actually, you should 20, in octal. Because this decimal 20 means a decimal 20. Whenever you say a number, you have to tell what number system it is in mathematical world, So this 20 will be, add a couple of more digits, it will be like 24 in octal, and you keep adding like 10, 11, 12, 14 in hexadecimal. And when we start writing the code, I'll explain how when we talk about in C language. Next we are going to C language, we talk about arrays for storing the values and pointers. What a pointer is, a physical memory storage. That pointer is a hexadecimal, meaning it's not, the address is like not 1, 2, 3, 4, but it will be like 0, X, and then combination of alphabets and numbers. That's what's called alphanumeric. This is numbers. Alphabets we know A to Z. So alphanumeric means combination of all the numbers and alphabets. So alphanumeric is used in a hexadecimal 16-digit address. So long, we'll continue in the next video.